Hello, my name is Danny Bradley. This is my Econ 380 Statistics Final, and I will be doing problems number 1 and number 4. For question number 1, it asks us, what is the probability that a randomly selected worker produces more than 66 units? And for this problem, we're going to have to use our z-score. First off, the z-score formula is z is equals to x, which is our statistic in this case, minus mu, which is our average, divided by our standard deviation. And I don't know what that Greek letter is, so I'm not going to even try. But our mu in this case, the average is 64, and our standard deviation is 2. But first off, why would you ask that we need to do a z-score? Why can't we just use regular probability? Well, our z-score essentially standardizes a given data set and makes it easily comparable. So we use this z-score to standardize this, and it tells us how many standard deviations away a data point is from the mean. So basically, when we calculate our z-score, it's going to tell us how far the data is away from its mean. So in this problem, the probability that x is greater than 66 is equals to, and punch it in the formula. So 66 minus 64 is 2, divided by 2 obviously gives us 1. So after calculating 1 from the formula, we know that our z-score is 1.00. In doing so, I've printed out a z-score table to make it easier to search. So for this problem, we're going to take a look at 1.0.0, and I highlighted the number, and that value is 0.8413. However, because this test is calculating more than 66 units, we have to subtract that 0.8413 from 1. So our actual answer turns out to be 0.1587, and that is the probability that a randomly selected worker produces more than 66 units is 15.87%. We now move along to part B of question number 1, which asks us, a random sample of 4 workers has been chosen. What is the probability that the sample productivity is greater than 66 units per day? So now in our z-score formula, because we have a population size of 4, that is our n. So in our z-score formula, it is not just simply divided by standard deviation. It is now divided by the standard deviation divided by the square root of our population. So we have n is now 4, our mu is still 64, our standard deviation is still 2. So 66 minus 64, obviously 2, divided by 2, and then divided by the square root of 4, which is 2. So now we will get 2.00 as our z. So based on our z table, as I showed you before, it is highlighted 0.9772. Once again, because this is a greater than question, we have to take that 0.9772 and subtract it from 1, and that is going to give us our probability for this sample. Shoot, my fault. So the probability that our x value is greater than 66 units of productivity is 2.28%, or 0.0228. Move along now to question number 4. Part A of question 4 tells us to determine your rejection region for a significance level of 5%. As based in the problem, our sample size n is equals to 81. Our standard deviation of their incomes on the island is equals to 50. Our null hypothesis is that our average income, mu, is equals to 300. Our alternative hypothesis is that our average income, mu, is greater than 300. We need the average income to be greater than 300 for our bar to be successful. Based on our alternative hypothesis being mu is greater than 300, we know that this problem is a right-tail test. Taking a look at our z table, 1.64 and 1.65 we see highlighted in the blue is 0.9495, and 0.9505. The average of those two is equals to 1.645, and that is our critical value for Z. So, our rejection region as determined by this problem is any value greater than or equal to 1.645, our critical value. We would then reject our null hypothesis. Lastly, we will look at number 4, part B. Determine the probability of a type 2 error. Assume that the concrete value for the alternative hypothesis is 310. A type 2 error means we failed to reject a null hypothesis that was supposed to be rejected. So you basically, in the sense of this problem, it would mean that we found the income to be less than or equal to 300 instead of greater than 300, and it was an error in the sampling. If it was greater than 300, we know we should open the bar because it will be profitable and successful. So, looking back at the problem, our z-score from before, x bar minus mu divided by our standard deviation divided by the square root of our sample size. In this case, we are looking for our x bar, so we have 1.645, we took that from before, and equated it to the formula. Using algebra, we get x bar is equals to 300 plus 1.645 times 50 divided by 9. And that comes out to about 309.14 approximately. Solving for the type 2 error, we get this here. We plug in the 310 into the equation as well as the 309.14 from before, and we get a z value of negative 0.1548, and based on the z-score table, we'll come out with 0.4385. So there's a 43.85% chance that there was a type 2 error made in this sample's data.